Now we get into the big ones. And a problem like E is much more common on the exam. Okay, we see with part E, twice f of x minus 3 times g of x plus 6 in the integrand there. And so we're going to start breaking this one down just like we've done in previous ones. And if we do so, we can make it equal to 2 times the integral from negative 2 to 5 of f of x dx minus 3 times the integral from negative 2 to 5 of g of x dx plus the integral from negative 2 to 5 of 6 dx. All right, we'll break it down into 3 integrals because we have 3 parts and they're all being separated by plus or minus. So we're allowed to do that. And then we can quickly see that this integral, once again, is going to be 4. So we have 2 times 4. And then minus 3 times 9. So we have 8 minus 27, which we know is negative 19. And what a lot of students want to do is say, okay, well, this is negative 19, and I need to add 6 to that. So my answer must be negative 13. And unfortunately, that's incorrect, okay? Because we're not adding 6, we're adding the integral from negative 2 to 5 of 6, okay? And that's not necessarily equal to 6. In fact, in this case, it's not, okay? So our answer is not going to be negative 13, even though it seems like it should be, right? Let's talk more about this third part here. We have the integral from negative 2 to 5 of 6 dx. Now think about what the definite integral represents. It's the area between the function and the x-axis from A to B. Let's make that. All right. So let's have a graph here. All right. There's our x-axis, and we're starting at negative 2, and we're ending at 5. So here's negative 2 over here. Here's 5 right there, and we're going to graph. Let me grab my blue marker here. Y equals 6. What's the line y equals 6 look like? Yeah, it's a horizontal line. 6 units above the x-axis. So when we look for the area between the curve and the x-axis, we have this rectangle right here. We know that the definite integral from negative 2 to 5 of 6, negative 2 to 5 of 6 dx, rather, that is going to be the area under the curve. Well, our area is going to be found by finding the formula of area of a rectangle. Area of a rectangle is base times height. Our base goes from negative 2 to 5, so that's 7 units. Our height, we know, is 6 units above the x-axis. 7 times 6, 42. That's the number we have to add to our negative 19. So we have 8 minus 27, that gives us negative 19. Then we add 42 to that. So we're looking at, what, an answer of 23. So even though it seems like the answer should be negative 13, in fact, it's going to be 23. This is more of the same on example 16F. It's a little more complicated because we have 2x here. So we're going to be dealing with some triangles instead of some rectangles. I don't know if you would necessarily see this one on the exam. You're more likely to see something in this regard. But you definitely want to be ready for something like this as well. Because you get the general idea is we have to realize that we're finding the area under the curve of that final term. Quick note before we get to this one. Notice if you don't want to draw the picture out, you can actually get the 42 from this rather quickly. Look at the bounds. What's the difference? Right? 5 minus 2, 7. Or excuse me, 5 minus negative 2 is 7. And we multiply it by the integrand. 7 times 6 gives us our 42. So you don't actually have to draw the picture, but you certainly can. Okay. All right, back to f here. We know that the f of x is going to be 4. We know the g of x is going to be 9. So we have 4 plus 9. And now we have to find the integral from negative 2 to 5 of 2x. All right, so 2x, that's a line, slope of 2, y-intercept of 0. We know that from algebra class. So if we draw this graph rather quickly, right, here's negative 2, here's 5, right, and we're talking about the line y equals 2x, so there's our line. Right, we have a triangle right here, and we have a triangle right here. Okay, this triangle we know has a base of 2 units and our height. Well, how far is this distance right there? Well, we just plug the x value, negative 2, into our function. Negative 2 times 2 is negative 4. So this is negative 4 down here. So it's base times height. So that's 8 We want half of that, which is 4. And because the triangle is below the x-axis, that means we want negative 4. All right, so we have 4 plus 9, and then plus, and the first triangle is negative 4. The second triangle, right, base of 5. Height, well, if we plug 5 in here, we get 10 up there, so height of 10. 5 times 10 is 50. Area of a triangle is half base times height, so half of 50 is 25. So we're going to have 25 from this rectangle, just as we had negative 4 from that rectangle. 25 plus negative 4 is 25 minus 4, it's 21. So we add 21 to our 13, so that gives us a total of 34. Right. So again, these two are much more complicated than the previous ones. This one especially, 16E, is one that we want to be prepared for on the AP exam.